Hello everyone, welcome back to the data analysis course. My name is Joshua Dara, and today we are moving into one of the most important tools in data analysis, which is Pandas. In the previous section, we learned NumPy and arrays. Today we will learn how professionals actually work with real world datasets using Pandas. By the end of this session, you would know what Pandas is, what data frames and series are, and how we load CSV files, how we filter rows, how we select columns, how we sort data. You also learn what grouping and aggregation is, and you also learn what handling missing values is. This is where things start becoming real data analysis. So grab your laptop, open your code editor, and let's begin. Now, what is Pandas? Pandas is a Python library used for working with tabular data. So think of Excel spreadsheets, database tables, and CSV files. Panda helps us manipulate and analyze this kind of data very easily. Now, here is something important. NumPy works mainly with arrays. Pandas is built on top of NumPy, so NumPy is the foundation. Pandas is the professional toolkit for handling datasets, and trust me, almost every real-world data project uses Pandas. Now, let's head to the installation of Pandas. To install Pandas, open your terminal and type pip install Pandas. When this is done, then you import it using import pandas speedy. Yeah. Again, we use PD as analyzed because it's shorter and cleaner. Now let's talk about the two most important structures in Pandas, that is series and data frame. A series is basically a single column of data. Example, import Pandas as PD, and let's give a variable s and as a series. And we print this. Let's run this code and see. Yeah. Now, a data frame is a table made up of rows and columns. So let's label this as series. Let's give an example of data frame. what we basically did here is we created a dictionary, and we want to convert this into a data frame. So to do that, we simply use pandas.dataframe, but since we've shortened it to PD, we use pd.dataframe. We are converting this to the data frame, and as I said earlier, a data frame is a table made up of rows and columns. So let's print this one too and see what our result is going to be. You will see that this looks like a spreadsheet, and this is the structure data analysts use most. Now, this is the data frame having rows and columns over here. This is a series also. Let's move on to see how we can load CSV files. Let's load a real dataset. Now let's see how we load real datasets like the CSV file. To load a dataset, say the CSV file, we use Pandas. Let's read CSV, then the file name. For now, I'm going to use a sample dataset, a sample CSV file. I'll share it later in the comments for you to download and also try. I'll share it in the comments for you to download it, also try working with it. So this is how we load a CSV file using Pandas. When we are done importing Pandas, we do pandas.read CSV file, and what we have here is a file name. I have the file here. You have to make sure the CSV file or the dataset is in the same directory as your Python file. Now, after this, let's assign this to a variable, say df. Okay, this single line loads an entire CSV file into Python. That's one reason Pandas is so powerful. Now let's inspect the data. So in inspecting the data, let's try this first one. Let me explain. Let's run this code and see something. Yeah. So we are trying to inspect this CSV file or this data here, and now the df.head shows the first 5 rows of the data in the data set. So whenever you load a data set or a CSV file and you want to see the first 5 rows, you should type the data set.head, because this shows us or gives us the first 5 rows. So let's assume you want to see the last 5 rows. For the last 5 rows, we use .tail. Let's run this to and see. So these are the first 5 rows here. These are the first 5 rows, and you can see some details over here. 5 rows times 9 columns. 1, 2, 3 times 9 columns. Fine. Let's run the last 5 rows and see. Now these are the last 5 rows. You can see the number here: 99, 98, 97, 96, 95. These are the last 5 rows. And from the previous one, so you can see the numbers there: 0, 1, 2, 3, and these are their indexes: 0, 1, 2, 3, 4. Yeah. Now let's also try this command and see. That's info. Now this .info method gives us the column names, the data types, and the missing values. Let's run this and see. So it has printed the column names. It has printed the data types over here. You can all see the data types here. The data type column here. You can see the column name. And you can also see the missing values over here. Those are the non-null count values. We can see all of them there. This is usually the first thing data analysts do when receiving a new data set. They check to see the column names, the data types, and some of the missing values in that data set. Now let's summarize the data set statistically. To do that, to make things easier, let me send this out so we can all see it clearly, and let me assign it to something here. Let me assign it to a variable. No, let me assign it to the variable results, and let's be printing the results instead. Now let's see how we can summarize the data sets statistically. To do that, we type our data set .describe. Our data set .describe, and let's run it and see. Now when we type this method or this function in Pandas, it brings out or gives us the mean, the standard deviation, the minimum, the maximum, and the quartiles, all automatically. This is one of the most useful commands in Pandas, so you don't have to now come in and write the code to find the mean or write the code to find the standard deviation, the minimum, the maximum, the quartiles of the data set. This simple command or this simple line of code can just give you all this information all at once. So the data set .describe gives us the mean, the standard deviation, the minimum, maximum, and quartiles all automatically. And we can see the results here. You can see the mean here, you can see the standard deviations here, you can see the minimum, you can see the quartiles, and you can even see the maximum here. Now let's see how we can select some columns in our data set. Suppose we only want to select one column, but first let's let's run this datasets.info and see the names of the columns we have. Here we have the column names are sale ID, date, customer name, product quantity, unit price, total sales, payment method, city. So let's suppose we want to select one of these columns. Let's say sale ID. So to do that, we type our data frame, which is df, that is our CSV file, in the square bracket, then the name of the column you want to select. We want to select the sales ID column. Now, when we run this, it is only this column that is going to be displayed to us or printed out to us. Let's try it and see. Oops, we ran into an error. Let's see. The error is just this code written here, sales.id. Okay, let's check. It seems we've not spelled the column name well. Let's check the column names again to see where our mistake is coming from. Oh, okay. It is sale ID, not sales ID. Fine. So these are some of the mistakes that you've been making, and you have to learn how to read the error codes that are displayed. So now we want to just print out this column. We really want the sale ID column. Let's print this out and see. Yeah, so this is our sale ID column over here. It is a 1 beside it here, 1, 2, 3 till 96, 97, 98 till the end. Now let's suppose we want multiple columns. So suppose we want multiple columns. For that, you just add comma, then the next column you want. So let's say we want customer name column. Let's run it and see. Customer name. That is not correct. Customer name. Customer name. Yeah, okay. We've missed out something. For multiple columns, you need 2 square brackets. Yeah, that was what we missed out inside. Let's run it again and see. Yeah, so now we have our sale ID and our customer name all printed out. Those are the only columns we've selected, and those are the only columns we choose to print. This is very important. You have to note this error that popped up over here. When selecting multiple columns, you don't use a single bracket. The single bracket only retains a series. Then just keep note of that. The single bracket only retains a series, but the double brackets retain data frame. Single bracket, series, double bracket, data frame. You can keep that in mind. let's see how we can filter some of the data in our CS form or in our data set. So let's run this command and see something. Let's see our sale ID in our sale ID column. Now what I've done basically here is to retain sale IDs that are greater than 70. So in our data set, we want to retain just in the column sale ID, the sale IDs that are greater than 70. Now let's print it and see. Yeah, so it has returned the sale IDs that are greater than 70. Remember, it's greater than, not greater or equal to. That is why it's starting from 71, 72, 73 till the end. That is one of the ways we can filter data in Python and in Pandas. Now let's filter by category. So let's use this payment method over here as a category. Now we are going to filter by category. We want to filter the payment methods that are done by cash. Okay, we want to filter all the payments that were made with cash. Let's try printing this out and see. Yes. Sorry. These are payment methods that are greater than cash. Should have seen it. Let's run this command again. We want to see the payment methods that were made with cash. So we are not trying to find the payment method that are greater than cash in the list order. So let's go back and run this and see. Yeah, so we can see the payments method done by cash over here. Payment method cash. So this is how we filter data in our data sets, and this is called Boolean filtering, and it's one of the most important skills in data analysis, because you can't look up through the entire data set to just find what you want to find manually. You have to filter to get only what you want and leave the rest out. So we want to look up something in the payments that were made via cash. So we only have to filter all the payments made with cash. Then probably in all the payments made with cash, we try to see all the sales ID that are greater than let's say 34. That is how we narrow things down in data analysis in a data set. So we just filter till we get to our results. It makes finding whatever we are looking for, or it makes the analysis much more easier and faster. Now let's see how we can sort data. Let's see how we can sort data. Let's give an example here so we'll see. let's sort okay, let's just sort the sale ID. I think the sale ID is already sorted. In default mode, it is going to sort it in ascending order. So if you don't want it in ascending order, yeah, so this is the sorted sale ID, or it was already sorted in the dataset. So yes, let me see what else we can sort. Something that is not sorted. Okay, let's try the CTS. Yes, so now it has sorted the city in alphabetical order. So we see A, B, 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 till we have our W. That is how we sort. So by default, it sorts in ascending order. So if you want to sort in descending order, we have to tell Python you are trying to sort in ascending order. So you are trying to sort in descending order. So you are saying ascending order should be first. Shouldn't sort in ascending order. And if you're not sorting in ascending order, you are sorting in descending order. Let's run it and see. Yes, so now we see it has started from the bottom to the first one over here. That is how we basically sort data, and this helps us identify, say, top performance, highest sales, best products, and trends. Now let's perform some aggregation. Let's see what aggregation is. Let's perform some aggregation. Let me type this command and let's see. So as we are doing this, you guys can all see that there are so much into pandas that can be done. You can see how powerful pandas is. Meanwhile, all we are just doing are the basic, some of the basic stuffs that, or the basic things that pandas can do. They can even do more than what we are doing. So just imagine how powerful pandas is in data analysis, for instance. Let's type this. Let's group by, let's see, we group by payment method. And let's do the column sales, sale ID column. Let's print some. Alright. So what I've written basically here, these groups the data by the payment method and sums all the sale ID. Actually, okay, let me not sum. Let's sum something that is true, like the quantity. Let's sum quantity. So it groups the data by the payment method and sums the quantity. So we are grouping by payment method and we are summing all the quantities, or the quantity column. This is super important in business analytics. You can also calculate the mean, the max, and the minimum. For now, let's run this code and see. Yeah, so it has grouped them by their payment methods and it has summed the quantities in those payment methods. So taking the bank transfers, for instance, the number of quantities in the bank transfer, the total is 98. So it has grouped them into the payment methods. Now the payment methods are bank transfer, card, cash, then mobile money. It has grouped them and it has summed their total quantities also. Can you see how powerful this is? It is very, very powerful, and it makes work much more easier and super fast. You can try this yourself with different columns, grouped by different columns and some different quantities. Yeah, it is very useful. It helps companies summarize massive data sets quickly. Now, let's talk about the missing values. Real world data is messy. Sometimes values are missing. So, as a data analyst, you are supposed to detect those values, those missing values. And okay, now let's detect some missing values in this CSV file and see what we can do about those missing values. Let's detect some missing values here. We want to check in these data sets, those that are now, and we should sum all of them and break out. Let's see some of the missing values in these data sets first. Yeah, so we can see that this shows how many missing values each column has. For now, we see for the sale column we have 0 missing values. For the date column, 0. We see that all of them have no missing value. Let's make one value missing and see the sale ID column. Let me go to the data set here and let's see the first one missing. Now let me run this command again and see. Yeah, so we can see in the sale ID column we have one missing value. There's something missing in the sale ID column, which we replaced here as now, like there's nothing here. There's something, it means there's something missing there. And you can use just this line of code to detect that there's something missing there. Now when you detect it, as you are not just coming to detect it, you are detecting it so that you do something about it. So when you detect it, you have to remove those missing values, otherwise it will impact or it will affect your data analysis. It will affect your analysis, so you have to remove those missing values. Now to remove those missing values, we simply use a command. We simply use this command, let's say df.drop na, or that is to remove them, or we use this command to fill the missing value spaces. So this is to remove the missing values, and this one is to fill in the missing values with something, or let's say replace the missing values. Handling missing values properly is very important in machine learning and data analysis. So try this out yourself. Don't worry at all. I'll share this sample data set with you guys so that you try some of these commands. You try to manipulate it, you try to clean it, you try to filter it, you try to group it, you try to do all some of these things that we are doing. You have to try it. You have to practice it. That is what will make you perfect. Now, let's talk about some real world examples where we use Pandas. Imagine you work for a retail company. You receive a data set containing customer names, product categories, regions, revenue, and order quantities. Using Pandas, you can find the best selling region very easily. You can calculate the total revenue very easily with just simple commands. You can identify missing data very easily with just this simple line of code that we've done. Though it can be a very massive data set, you can analyze customer behavior. You can also generate business insights. This is why Python is used. This is why Pandas is used in finance, healthcare, AI, marketing, engineering, and even scientific researches. So, some of the common mistakes that most beginners do. Let me speak about some of them so that you keep them in mind and avoid doing them. Now, forgetting column names are case sensitive. So you see the error we got earlier when we're trying to only bring out the sale ID column. I wrote sales ID instead of sale ID, just that single addition or omission that will be done will affect it. So even if it had been, say, if the column name was sale and I write sale, let's say I start the beginning with a capital letter or an uppercase letter, it will still bring an error. The column names are case sensitive. So don't forget the column names are case sensitive. Now, using single brackets incorrectly. Remember, I told you single brackets are used for series and double brackets are used for data frames. And we know data frames are those in columns and rows. The series are just a single column or single row. The data frame is both column and row. They are tabular forms. It is in a table or in a tabular form. Now, another mistake is ignoring missing values. As a data analyst, you are never supposed to analyze dirty data blindly. So whenever you receive the data, you have to do some of this analysis with the data, and you have to check the missing values in the data and either replace them or drop them completely in the data, because it will otherwise, as I said earlier, greatly affect your analysis, or yes, it will greatly affect your analysis. So never analyze dirty data blindly. Another mistake is forgetting parentheses on functions. So you see that all the functions that we are writing, we always add this to them. It's now we added this, added the brackets to it, dot head, we added the brackets to it. We always add the parentheses to the functions. So if, say, you had written df.head and you had written this, try to print it, it is wrong. You have to add the parentheses to it because these are functions. They are functions. There's now is a function. The sum is also a function. They are all functions. The drop now is a function. Fill any is a function. So never forget the parentheses on the functions. Now, your assignment for this session is to load a CSV dataset using the read CSV. I'll share the CSV files with you so that you load it and see. Then 2, you run .head, you run the head function, you run the info function, and you also run the describe function on it and see those 3 observations. Then 3, you filter the rules where, let's say, the cells are greater than 1,000, or just filter the rules in which the cells ID are greater than a value, and the rules from a specific region, and also the top 10 rules by revenue. After that, group the data by category and compute the total sales, average sales, and count. Find and handle all missing values also. Then post your solutions in comments for feedback, but I'll share the submission link for you guys to submit. Now that brings us to the end of session 4, that is Pandas and data wrangling. Today we learn how to work with real-world data sets professionally using Pandas. In the next session, we'll move into exploratory data analysis, also known as EDA. That's where we'll learn how to truly understand these data sets before building machine learning models. If you enjoyed the session, kindly like the video, subscribe to the channel, share with friends. Thank you for watching, and I'll see you in the next class.